Hi, my name is Edward Unthank. I start with a little bit of an introduction about myself. Hi, my name is Edward Unthank. I start with a little bit of an introduction about myself. Hi. Try this again. I'm new to the world of live streaming, so excuse me while I make a lot of mistakes all in a row and then try to edit them up and at the end of this, and we'll see how much we can get out of this. But it's at to the point where action is no longer optional, and sitting on the sidelines is not something that I'm interested in doing. Because in my opinion, we're in the beginning of a new era of civilization for humanity. We have a new technology that's been unlocked, and that technology is artificial intelligence. And I've been listening to this a lot and trying to figure out, what is artificial intelligence? What's the hype media? What's the fakeness of it? How real is any of it? And the answer is, after diving deep into it, as a developer who's been a kind of a front-end code purist, as an origin story, doing WordPress development, and then going into making websites, and then going into an agency world, and then taking over marketing technology for lots of big, large companies, and figuring out how to run all of that at scale. I've been at the forefront of a lot of the cutting edge technology, and that's the thrilling part. I love being around brilliant minds, and wherever they are, whatever their specialty are, I just love that. That is inspiring to me. But I've been trying to challenge myself as an entrepreneur and as somebody who's running a few companies, including tech consulting companies. I've been trying to learn from the bleeding edge, the cutting edge, the point of impact. And the point of impact right now is currently into the public communities is something like the OpenClaw community, which is a Discord. It's a bunch of Discord conversations happening about artificial intelligence among the nerds who are actually building these things. And so that has been where I've been spending all of my time. All of the last month and a half is trying to learn from the bleeding edge. I'm trying to drink from the fire hose, they say in business. I'm not just drinking from the fire hose, we're drinking from Niagara Falls right now, and trying to consume it and turn it into consumable bites of intelligence that are repeatable. That has been the challenge. That will continue to be the challenge. I'm here to try to say, hi, I'm Edward Unthank, and I'm here to pursue the challenge of wrangling AI to making it intelligent enough to be communicated to everyone else, and also talk about how this is going to impact civilization in hard ways, as well as to come up with an idea that this is a rallying cry, because there's a lot of impact coming down from this. We will see it hit a lot of the economy, and I think we need to I think we need to specifically prepare for it, because if there's a natural problem coming at us, if we see a tidal wave in the distance, there's only so much that I want to sit and cower and hide my head and just deal with the feelings of what that evokes in me. And then I've been thinking more about it and thinking that this is an existential threat to knowledge work. I employ a lot of knowledge workers, aka computer workers, aka remote work. And in that remote work, I'm thinking about, what does the future look like, and how do we make sure that we can catch this wave instead of being destroyed by it? And the only way to do that, I think, is to take action, and it's to build positively with the new tools that have been unlocked. And so with that, I say, welcome to the great AI race of 2026. I'm trying to learn as fast as I can. It's my job. I'm considering it my night job, and my dedication for the next total of 180 days until June 30th, 2026. I am dedicated to learning as much as I can and dispelling it into consumable chunks, and then spreading that information as far and wide as we can, because I've been dealing in this from the dredges as a developer, and saying that something that used to be impossible before would take hours and weekends of me alone as a developer who can code. Bringing an idea to reality has been just an extraordinary amount of time in order to make it happen. And now we can do that exact same thing so much faster. I was able to spin up an idea of a project that I use to test myself and my skills and grow. And I usually choose a side project and I build toward it. I've been able to make something like that in a matter of 3 hours with new technology, and it's gotten further and better than I ever could have done as an individual developer. That's wild. That is incredible. That has impact everywhere on business and the economy, the microeconomy, the individual companies, the macroeconomy, the level above that, and even what I'm trying to define is the hypereconomy, which is the layer zoomed out even from the macroeconomy, where we're looking at international, everything about international competition towards the improvement of the human quality of life. So here are some things that I've been learning, and I'm trying to turn these into some nice bottled learnings, I say, in order to be repeated. The first thing is that what does AI mean? AI, what is it anyway? So here's the thing. AI actually has a lot of different meanings, and I'm going to define this based on what level in what I say the stack is and the stack of abstraction. So the first one is level AI, and I call it subprime 0. I haven't heard of better notation, so we're just going to call this Edwards notation. AI 0 is to say on the abstraction level of math, and this is math retraining large, this is purely on the mathematics basis. This is when we were, anyone who's been watching this back when they remember that OpenAI used to mean open source. That's because there was a race in academia in order to create these in math labs, in actual research, and Harvard and a lot of publications. And the whole point on this is to have a new approach to math, which is what I call basically it's math and it's statistical regressions and statistical models. And then even more than that, specifically this AI subprime 0 is just this world of kind of the research, applied research math. And this is the core of what NVIDIA does. When you say, what does NVIDIA actually do? It's actually basically saying, we've realized something new. The old model that we've been working on of coding, this is the hidden paradigm that we haven't even enabled until now because it's so implicit of how we've been doing things, is coding. And coding is gone from what I call explicit linear, and that means that you tell it every single code, every single line of code. You say, do this, then this, then this, then this. And this has been a linear model of code. That means there's one giant thread. You can turn every single website into a single continuous line of text. And then it just gets gobbledygooks eaten up and then sorted into what we see on a website. But the core of all of this is we have linear coding is the paradigm. What we have unlocked as a civilization is a movement just from this linear into parallel coding and parallel processing. And the whole point of this is that when you're doing a linear model, you can get, if you're really clever, you can get up to 3 streams, 3 lines at once. And that's about as far as you can go. With parallel coding, we have an idea of saying, instead of taking one line of code and then feeding it through as fast as we can, what if we divided everything into, for example, every pixel on the screen? Every pixel on every device that you use is independently calculated as a formula. And it's done in so rapid scale, it's every single pixel. We're into the absurd quantities of pixels being constantly computed. If you're watching this, you're seeing your device on the screen compute crazy amounts of formulas in order to determine what color you're seeing on every single dot on that device. That is the parallel approach. And we have learned that what if we just embrace this model and then went with maxing out the parallel computing approach. And then we found that if you apply this and take every single one of these, instead of a pixel on every single device being calculated, what if you move it forward? And then what if you did something more valuable with that than determining if this should be red or blue? Well, there are other uses, but we've already been doing it. So how about we just take that graphics card that NVIDIA does, and NVIDIA used to be like the gaming hardware. What if we retook that's coming up with the pixels, and we reprogrammed it to do statistical models at absurd scales? The problem is that, rather, the unlock that has come from that has been a new paradigm of thinking and programming, which is out-competing what we thought was possible. It's out-competing what I thought was possible. I really thought linear is the model to go, and the linear coding paradigm was the way that it happened. Turns out when you go with parallelism, you can then have independent things running at the same time, and then you can do things that are just absolutely incomprehensible scales, because every pixel can be a formula and every pixel can be beating and growing these things. So AI subprime 0, this is basically the research layer of math. And as my background in statisticals, in undergraduate of statistics at Seattle University is, or rather economics, is to look at and take the learnings from that. So in econometrics, in my classes in econometrics, it comes up with a key paradigm where you say multilinear regression at the time was about as far as the math world was going. And that's about my extraordinary depth where it ends there. So multilinear regression is the key thing. But in order to do this, you start out with saying, to properly do statistics, you say every single, and I can't even remember the notation anymore, but every single variable where you think there's a number here that's like the driving number, and then you say every one, it turns up with something like an X and something like a, and I'm sorry that this is, I should probably just look this up before just writing the wrong thing on the screen, but I'm going with speed because this is a race and I need to lower my standards in order of just not doing anything. So what you do is, you're basically coming up with a really complicated math model, and then you have to put all of your thought into designing it. Which means that if you say, for example, an example is we wanted to determine the impact of sales on, and this is an actual process that we did in class, would be say you wanted to determine what a company's sale is, and you have a revenue number. So you have this one right here, and it's dollars, and it's dollars per day, maybe you might say. And then you identify what you think are the impact variables, the things that'll actually move this number. And you have to spend most of your time deciding what are going to be the ones that you choose, which variables impact these things. And you need to be smart ahead of time, because there's a core mathematical model here which says basically if you run something 100 times and it's calculated as a 95% statistical significance, they say. If it's above a 95% statistical significance, that means that if you run a model 100 times, you'll get the right answer 95 times out of 100. That also means that you'll get the wrong answer 5 times out of 100 times. And so the key driving paradigm in proper statistics in the academic level is that you design this so well and so purposefully up front that you have them already bulletproof. So you say, okay, a dollar per day, what drives revenue per day? Well, it'd be, what's the weather? You'd say, what are the other things that you think would change how much you make? Well, it'd be the weather, it might be the temperature, it'd be another number that you could put in there. There could be basically anything that you could think of. But the entire point is that you choose one and you maybe run it 3 times. That's your goal. You want to run this model as minimum amount of times as humanly possible, because you know that if you run it 1,000,000 times, you'll get 1,000,000 times 5%. It will be wrong. They'll be aligned, but they won't be accurate. And so this has been the foundational piece of math is making sure that we do this. Now, this all started in research. And what happens is all of this math is AI subprime 0, I say, is like the core mathiness basis of artificial intelligence been renamed. Another example is deep learning or machine learning, and whatever is the moving top research paradigm at the time that's going to be defining this. At the moment, I think the leading is deep learning, and I expect that to change very rapidly as we see technology improve. So AI subprime 0 is basically saying, okay, what if we took this multilinear regression model, except instead of running it conservatively 3 times and getting the answer, what if we ran it every single pixel on the screen at the same time? And then someone did it. And that has been the unlock, is because this AI subprime, when we're talking about this, has been primary in languages like R, which is like, it's done by mathematics. It's done by mathematicians. These people are thinkers and they are not code purists. I've been in the dev world, and the dev world is entirely different. You're looking for optimizations and speed, and you're looking at how do you do things as little code as possible, as well as you can. And that is the core difference, because AI subprime 0, which I'm going to call like research math, is all been being led by the academia. The problem in how you actually do that is you come up with the math, and then you press a button, and then you walk away for an hour, and then you come back in an hour, and if you're lucky, you have the results of your test, because you've programmed it in such a slow computational way that it's just basically been impossible to do anything beyond 3 tests at once. The paradigm change has been to use this kind of, I call it brute forcing multilinear regression, or brute forcing any of these statistical models. And it's basically to say, instead of 5 times, what if we did this, let's do this infinite times. The goal is toward infinite amounts of tests with infinite amount of variables, times an infinite variables. And then that leads to what we consider the extraordinary amount of math that turns into AI subprime 0. So this is a world change. This is what if we mapped not just 3 outcomes, but every possibility of an outcome. And that approach has led to this new unlock in technology. This is the foundational layer of the unlock of artificial intelligence, is on the research layer of abstraction. So that's the research layer, and that's what we call the subprime 0. That is the core of everything. And now we start to look at what are the next layers of artificial intelligence, because there's AI subprime 0, and that's on the core academia and math basis. And then we need to go into the other layers of abstraction beyond that. So the first layer of abstraction that's turning into being applicable is to say, how do we have basically to say a new approach of a computing paradigm, which is solve for X. We've never been able to have a computer solve for X so much as in this new change. Instead, we used to say before, it used to be 1x or 1 times 7 plus 3 to the power of whatever, and you just keep on adding it up. It ends up being a linear math model. This is instead switching that on its head and saying, what if we took this brute forcing approach from AI subprime 0, and then we started to use it as trained to anything, but we'll convert absolutely everything into math. And that is the new unlock that is AI subprime 1 for civilization. This is everything turns into math. It doesn't matter how you do it. It just matters that you do it consistently. And then we take that math and then we run infinite different stats model experiments to determine what moves the independent numbers. And then we use approaching an infinite amount of input variables, and maybe tokens, whatever you want to call it. And this is where we say solve for X, and there are first applications on here that'll be into the next one, because AI1 leads into AI2. AI2 is going to lead into AI 0 into AI1. AI2 is the next subprime. And then in this one, we talk about the application layer. The application layer, I mean that not in a coding term, but it's how do you apply this in towards something? So that's what it means, and that's also where the language that we've been working with in a linear coding paradigm needs to be updated. So what I've been saying a lot is we need a new dictionary. We need to be able to talk about the same thing, because when I say AI, people hear 4 different things. If I'm lucky, only 4 things, but really significantly more. The applied layer or application layer is to say, what do we want to take here, and what do we want to turn it on to? And the answer is, we've first figured out that language, specifically text, written words can have an extraordinary amount of impact as we've seen it. And this is where, when we have AI applied to words and this mathematical brute forcing, then we have been able to get large language models. So the first application layer is the most common, and that ends up being words, and words end up turning into language models. So we have to determine that there is this variable right here called large, and mostly we've been starting, the American approach has been to start with infinite scale and determine what patterns we see from it. And from that, we have seen an extraordinary new use of chatbots and of the very beginnings of the foundation of a new technology. Now, it's being used not very intelligently many places, and it can be used well, and you need to be able to understand the quality of it and how much it is nearly a simulacrum of guessing the next word. Because that's really what the key is. So the large language model, this is my hypothesis on how it works, and based on my understanding and stats as developer and as business person and everything else like that, is really the core Lego that we're working with here. The core Lego is what's the next word? I can't even do it in there. What's the next word? And then what we say is every single test, every single word, we say, what's the next word? And then we build it out, and then we keep going. It's the same thing as if in your iPhone, you used to have fun with having the recommended word, and you just tap out the recommended words, and it sounds something that's kind of like you, but it's not you at all. But it's based on the most frequently used words in your iOS keyboard, for example. So here's the cores. We have what's the word, and then there are different bottled companies that are coming up with models that are the core back end of this. They basically run the simulation an infinite-ish amount of times, get the quality is up as much as they can, and then they bottle it into a little teeny Lego that's only function and is led to say, what's the next word? What's the next phrase? What's the next word? And then from that, this is the core. So this is the core large language model core right there. And then we're seeing the next layer above that, which is being used, this being used, large language models being used in order to have language be the driver of code as opposed to humans driving the independent code, and how that means that language also is an enormous unlock for the ability of humans to learn. Similarly, it's going to be a huge unlock in order to teach robots or AI, artificial intelligence, and I mean that in the math layer, not in terms of some grasp on sentience, of figuring out what this is. So it's always what's the next word. Now I think there's into now an AI 3 level, and the AI subprime 3, Edward definition notation. I'm open to suggestions. I'm terrible at naming things. That's why I'm just going with numbers. As we see, now we bottle the large language model example. If we're going off of that tree and that evolutionary tree and evolving tree, we say large language model, and then there's a chat person where you say, hey, what's up? What's your name? But there's actually in the back end, it's not just this one Lego, it's this Lego multiplied by 100 Legos in the back. So there's just, when you fit in and ask a question, it does what's the next word again and again. And the fast increase in quality is that we've learned how to have consistency from verbal feedback. And so what we say is every time you ask one of these large language chatbots about to do something, what it does is it guesses the next word. And then my hypothesis is that behind the open AI doors, aka the closed AI doors now, because everyone's guarding secrets, is my guess is probably like 1,000-page context feedback loop here that chains together the first original question, and before it's fed back to the user, the answer, it goes through an iteration loop, and it says, is this any good? Did I do any good job with this? And it has basically like chained together 1,000 additional quality assurance, QA, quality assurance prompt modifications or improvements. And it includes the really silly things like don't hallucinate and everything else like that, because they're becoming part of the feedback loop. So if you say to you start with the silliest starting point, and then you manually prompt and improve and improve and improve, that's what you can do the same way. If you just use this core Lego and swap out this what's the next word Lego with smarter math models, you can then feed in the same iterative improvement loops, like just this, did you mean it? Can you check the math again? Everything that you can think of that would be a standardized criticism gets baked into this application of the 1,000 times 1,000 feedback loops. And so that's where AI subprime 3 in large language models is in the current place. And then we get into this fun area where we have a new civilization technology unlock, and that is that by this large language model, you can have a computer nearly act intelligently as an AI agent. And now that's the current nomenclature, an agent. It just is what it is. Some people call them bots. It doesn't really matter. But it's basically to say, now that we have this language, foundational operating system in language, we can use that to have a language-based stack of technology. And this is where we get into having a feedback loop with OpenClaw and with co-working functionality where you can talk to a chatbot and then have it walk through things. And it's more and more growing so that the AI doesn't just talk, but we can enable it to take action as well. And this is the action layer. It's AI with action, not just words. And that action application here is showing extraordinary revolutionary new things, such as you can have one human. If you have one human, and I'm just a human, for example, and I try to act as smart as I can only output from my brain so much because I can only bring the ideas into reality based on hard work and merit and really hard work. And so this one human ends up having generally, before this, we just call it like a 1x output. Now there's a new model where I could speak into a camera and then I can have it recorded and then I can take that as core data and then apply additional multipliers on it. So if I am a human and I know how to do a computer, I might be able to go 10x as fast as being able to, I can type 10x as fast as I can write. And so this would be, for example, a pen and paper mathematical return of a different approach on like, well, how do we increase the output of humans? And one of the ways is first, we imagine before computers. I think we'd say the standard we can say is the speed of output multiplier is something like 1x to that person. So that's if you're writing by pen. If you're writing by computer, you might be 10 times as productive. You can do 10x as many things. Now we're getting to a world where it's not just 10x computer, but we can have 10x, 100x if we have one computer multiplied by action layer that can run 100 times as fast. And this is when we have a co-working model with a large language. Agent co-working, we get to 100x. And then we start to look at how do we have more than one agent at the same time. And we get into this next logarithm growth step where we say some people have figured out how to have 10 individual agents running simultaneously on a single device, talking to each other in parallel. That is the next model. We have multi-agent per computer. Now we have somebody into 1,000x productivity as a paradigm compared to a pen and paper. We keep on going because this is a logarithmic growth scale. So instead of that, now we have 10,000x. And how do you get 10,000x? 10 agents on that is their new future things as well. And the next one has been multi-device. So multi-device means that you can have each device can hold 10 agents. And so if you have 10 computers, 10 devices in parallel, you get a 10,000x return on the independent human hour. And that's turning someone's brain into actual real output. That's taking action with your time because it really just comes down to hours. What's the multiplier of hours and how it ends up growing these things? So this is what is unlocked. We've unlocked a new way to have massive amount of output and scale per human hour. That means that this is going to be a rapid surge of growth. The implications for this are significant. It's imagine if the smartest people in the world, the extraordinary thinkers of the world, had the ability not just to be working on 10x as a computer, but to be able to be jumping into 1,000x productivity of being able to act on actions as quickly as they come up. That is the new world that is possible. That is the new paradigm. So let me run through these again and come up with a quick summary, and we can wrap up this specific subsection, because first, in order to talk about anything about AI in the world, we need to be speaking the same language. We need to understand that there are many definitions of artificial intelligence, and these are the ones that we're going to be focusing on. There are other components as well that you could argue, such as artificial general intelligence. I'm not really going to be talking about that. I think that might be a future thing, but I'm interested in saying, how is civilization changing just with what we have unlocked so far? What is possible so far? And in that, I think there's a lot. So again, to summarize, AI subprime zero. This is the academic models. This is brute forcing, for example, multilinear regression. And it's things where as I was taking postgrad math class on this and statistics, the core paradigm was choose what you do and don't do an infinite amount of replays. You don't get to just choose and spin it and spin it and spin it until you get a result you like. You have to be structured up front in order to make a trustworthy output. Instead, we've taken that and said, now let's turn that into solve for X, and a machine that solves for X where we turn everything into math. We can start with language, but there's also every other medium and every other type of data to be done. There's images. Every single pixel can be described on a screen as having a certain color that can translate into math. If we feed that as an infinite amount of inputs, we can feed it into an infinite amount of simulations to run these compute models again and again and again, faster than a human could comprehend, at extraordinary parallelization, instead of waiting an hour, pressing a button, seeing it, changing some things, and then pressing a button and waiting an hour again. That is AI subprime 1, brute forcing math as a specific model. And this is where NVIDIA has come into play. So deep learning, and then we get basically how do we run massive parallelization? NVIDIA has been the one to do that. And that's why NVIDIA has gone and exploded in size and stock and everything else like that. Then we get into the next layer, which is how do we not just apply this to anything, but specifically, let's take one applied layer of solve for X, and we're going to target words and language. And that's what we've done. And we've seen it's gone so much further than I would have anticipated in the quality of this, coming up with things that seem intelligent. It's useful. It is astoundingly useful. It is not expected that it would have been this useful, but we have it and it's here. So what does that mean? We've got the NVIDIA application layer. The primary one that I see is large language, but I want to call out right now that that is basically just a voice box. There are so many other types of data that we can be looking at things, and we just haven't seen those take off extraordinarily yet. An example that I can see, for example, is math. I've started to see some research papers that are taking this math approach, where if we're teaching someone if we're trying to attempt to brute force teach a computer how to think in language, it'd be much easier to start with easier foundational things that are less messy. An example is math. If we can teach something algebra, then we can, and it's very good at finding patterns, and that's really core of what it is. It's like if you run something 1,000,000 times, you'll catch 1,000,000 patterns sometimes, or you'll catch some, and you can improve upon the ones that work, and you can not invest so much as what doesn't work. But there are other things in here. One of my core ideas I keep on thinking about is in the area of innovation, there is, for example, electromagnetic frequencies and being able to capture them. So, for example, we've learned that a large based on the Fourier transformation, that you can take one huge recording of everything, run some math formula on it, and then be able to come up with specific of, in this wavelength band here, you get this being in here, and it's a combination of those all together. That means that there are fundamental inherent patterns in nature that we can feed into this machine, and then we can not just look for text, but we can look for anything else that are inherent patterns in nature. And because there is fundamental consistency of these, because of laws of physics, for example, we can use those in order to describe accurately not a specific linear coding of these things, but a solve for X application. So there's more path here. I consider it kind of a fractal of growth. We've got AI subprime 0 is one subset of a fractal. AI subprime 1 is another subset. Subprime 2 is another subset. 3, and then 4. And these are examples. This is what we're currently seeing, and people are talking about AI. Now, I say generally, you know, I love and hate that somebody named this AI a long time ago, because it's not artificial intelligence. That's really the ambitious goal and the direction and kind of the mission of what this is. The AI is an ambitious title. It's really, it's math. We're just brute forcing math, and we used to call that deep learning in the academia research papers. But there's even more to it nowadays. So this is the core, and I propose that this is kind of a unifying language that we do, where we build up from the core of a AI subprime definition, and then this is how we need to harden our language in order to talk about things better and better, because there's no going forward if I say AI and somebody else hears other things. And if somebody is on the layer of chatbot conversations, I think it's important to understand the foundational, that this is mathematical guessing the next word at its core. This is something where if we iterate it on it again and again and again, it's getting closer and closer to something that seems intelligent, but artificial intelligence is not exactly here. But I do think it's basically the goal of the roadmap. It's where they're trying to get. What that means is in the interim that you can have little like nice or unpleasant hallucinations. If you don't have a strong mental foundation, you can be tricked by any of these, especially if you think that there's so much secrecy, or not, rather that there are hidden patterns within here, that you could take that seriously. And if you don't watch out, you're just coming up with context paths in here, an infinite amount of dimensions and an infinite amount of math world. It's like the matrix multiplied by depth, multiplied by dimensions that we can't even consider. And that's being an analogous, not a literal description of metaphysics. But what happens is, in this ginormous box, it's like electrical light. You go through and then you follow the path. So if you, for example, you can see that a large language model will change its response depending on how you're talking. If you talk to it like garbage, it'll talk back to you like garbage, because it's going back to say, what is the most similar language that I've learned along these paths? And if you start to talk to it like scary science fiction, it'll do it. If you start to talk to it with its other trained languages that feed the model, which is all text that's been written, basically, then you can get into having a different path of having more productive things. So for example, I try to talk to it like I would any employee, polite, kind, succinct, and biased towards action. And with that, it acts similarly and responds in a very similar contextual fashion. Similarly, if you can come up with the other things that are trained on different data that's less everything and more specific, that's where we get into distinctions between, if a large language model is looking more like a grok, which is to say a more controversial, trained on a plethora of cultural information and not trying to be hardened down to a pure logic layer. And then that's how we get basically kind of different personalities. They're trained on different subsets. It's like if you can imagine that you fed AI just trained on Reddit, it would just talk to you like Reddit, like a Reddit comment. Now that's pros and cons, and you just need to be aware of what the training data is, and then be aware of that's what the reality is that we're going to be getting out of it. And that also means that you can navigate this black box system of a large language model, which is so large we can't even comprehend the amount of math going on here. And it's just in a race to infinity of amount of math. And so you can go into any other path and you can get it to talk like other things that it's heard similar path. It'll talk the talk. That's what it does. It's trying to talk the talk. There's not exactly action on it yet, except for the next layer where we get into AI subprime 3. And this is the application, not just the Lego, but the contextualizing, trying to steer it toward high value human output for humans. That's the AI 3. AI subprime 4 is where we start to aim this with specific, or you could probably even argue it's the same as AI 3. It's basically being able to encode action into it, but with a language as the programming language. And so we can build from here to say, we don't need to have everything in the exactly start in the ones and zeros and linear, but we can say the foundation of our new stack is going to be basically, I'm going to say large language model, but I'm just going to switch to say language. And language is the foundation that we can use here. If you scale with this, then you say AI, and then AI robots can be basically communicated with to and from just based on this text language as the foundational layer. And then from there, you can add additional intelligent ways to do it, where you say, well, shoot, if I can speak into English with one robot, how about I have 10 robots speaking to each other? Call that AI agentic, and an agentic framework that is quickly growing here. And then this keeps on going. Like, we'll just keep on seeing this stack until this whole stack, this whole AI pile, this whole AI stack ends up being a core of a way to have an entire computing approach. And that's what we're moving for. I say that we're applying this foundational AI subprime 0 or this AI subprime 1 of solve for X. We've just applied it to language and words. There's so much more. We've basically figured out a single finger use case for artificial intelligence. There is so much more. There is inputs, there's outputs, there's audio, there's video, there's seeing, there's hearing, there's all of these together. It just turns into an innumerable list of innovations, because we've only done a singular one and it's been astoundingly effective in reality. Like blows my mind how effective this whole thing is in a way that I never expected before, and in a way that I think is kind of the future and the foundation of the future. So is my first recommendation. Edward Unthank, I'm trying to come up with and turn this into an every person descriptions. I'm trying to make this sense for my the regulars at my coffee shop who are there and I like to chat with every day. I'm trying to turn this into deep with the mathematical people who are into the research world. I'm trying to talk with the coders who are in the 1000x world, actually coding in the agentic AI and agentic layer and building out from that and rebuilding entire computing paradigms based on this kind of AI first paradigm. This is it. This is what we mean. It actually means things. It's not buzzwords. Buzzwords are just big words referencing big context. If you understand them, you can learn to think faster and talk more quickly while still having precise meaning instead of having obtuse hand-wavy meaning. So in order to move forward on this, we need to start to understand the world and start to understand the components of this world, because I think that we have unlocked an extraordinary civilization unlock, a technology level civilization lock for humanity all up. And we are just in the first sentence of the history books. This is just the beginning of how this works. This is the beginning of anything that we're starting to do from here. It's all in this AI layer. So I would say again, I suggest something like we need to come up with a hardened and shared language. I haven't seen anyone do it, so I'm just going to start coming up with it. I want collaboration and better ideas. I'm great at coming up with systems design, system thinking, but we need to come up with a communal language and a communal description of how to talk about these things, so that when I say AI, you can hear and we start to talk in the same contextual language in this huge black box of language and how it works for artificial intelligence. So Thank you for that. This is the first chapter of what I'm hoping to be a multi-chapter series on what AI is for the every person, for the math nerd, for the developer, and how this is going to impact our society and civilization. Someone has to do it, and the future is going to go to those who build it. So this is a race. I call it the Great AI Race, and it's an international race. And whoever is able to take this new civilization unlock, this new technology unlock, will be able to be growing so quickly. They'll be going at exponential speed. And if we don't wake up and start to act and build positively toward a positive future, we're just going to have to deal with whatever the outcome is. And I think that this is power itself. I think the new race needs to be on brains, not brawn. And I think we as civilization need to have a healthy competition and have a healthy international rallying cry to say, let's build toward a better future. What is the way that we come up with a better human quality of life? Let's build toward it. This can go a scary direction based on this, or a better direction towards somebody's approach and a kind of universal values, and coming up with a system and a way to talk and measure to everyone. And things that are never been possible are now going to be possible. And there are some scary things that can be built because this is an enormous tool. And if you use it smart, and and it doesn't matter really, whatever the focus is, that's what you get out of it. So I think that we need to start taking this seriously as a society, as Americans in business, in everything. We need to start acting on this before this overwhelms us. And we're in a race, and it started already. And it's a logarithmic race, meaning if we wait more months, the competitors are going to be so far ahead that it'll be absolutely impossible to catch up. We are now in a point of disruption that's actually possible to make this happen. We need to do it together. So that is what I start with here. I'm trying to turn this into a consumable chunks. Thank you for joining on one of my first live streams. Thank you for your patience. And I will see you into the next ones. And I will be here and on every channel. My name is Edward Unthank, and I'm trying to help us rally this technology for economic development and for good, not for a scary future for our children. In order to protect this next generation, the next 3 generations, we need people to step up and build positively. And that is the way that we have a secure future, is to actively build one that we want, because this has reached critical mass. If you sit on the ground and do nothing, if you sit on the sidelines and do nothing, we will be lapped by other people, and they will be so far ahead, it will be impossible to catch up with them. And so it is a massive disruption a moment. The race has just started. Whoever takes this seriously is going to win. The first people to take this seriously are going to be so far ahead in this race that anyone who just has realized that the gun has gone off for the race to begin will have no chance to move forward. So take your advanced learnings and then start to dedicate your time into learning this, because this is the rallying cry in order for us to improve civilization. This is for us to choose and to enact good things and good outcomes for a secure future for the next generation and the generations after that. And that'll be a consistent rallying cry, and that is my consistency. I'm going to be learning in public and building in public. Come watch, come learn. There's a lot of noise out there. I hope to be focused just on the good stuff. And that means unique thoughts made by my human brain and multiplied by artificial intelligence execution, while the core human brain is the one that matters. Whatever the quality is and the consistency on this is the outcome. AI is only going to be as smart as the driver. And so you need a smart driver and the driver's seat in order to have the outcome, because you can multiply something times 0.1, or AKA is like a human, starting human brain quality output multiplier. But when we have this, it's kind of a systematic groupthink by mathematics. And so the human drivers, I think, are the ones who are going to be making this achieve impossible things and building the future. Welcome to the AI race, the great AI race. It's 2026. Even if you've never heard about it, the race has begun. It's time to get going. Join us. Let's build a better future that we want to live in instead of one that we're terrified to live in. We can do it, and it doesn't take corporate action. It takes an every person action and coordination within them. It's not corporations, and I don't think that's a solution to our future. I think we need to be able to launch 1,000 boats in 1,000 directions, because every single subset of this can be enumerated, mapped, and coming up with an action plan in order to make an incredible new improved way of life and quality of life, where we can focus on being humans and maximizing our quality of life in that, instead of spending all of our time being paper pushers in a computer world. We can automate the paper pushing now. And I think that doesn't have to be just terrifying. I think it's inevitable. And I think that means that we need to prepare for it. Thank you. Tune in next time. I'll be streaming randomly as I figure out how to stream. And as I figure out how to have emphasis across these things. You'll find me on some Discord channels and on LinkedIn. Look it up. My name's Edward Unthank. I'd love to talk to you. I love talking to humans. Let's talk. Let's collaborate. Let's figure out how to map this out and take action. Because I'm a doer, and I want other doers to join us and make this happen.